95% lower confidence lower limit is 0.033 and the higher limit is 0.185. So if I need the confidence interval of Y prediction for a 2,000 square foot house, I would do this. The lower value would be the intercept plus the slope times the size of the house, and the higher value.
What was that again?
You probably got a mistake here. Wait a minute. So F2, no, this will be BF, B type. So this thing times this plus the intercept plus the slope times 2,000, the lower limits. That's that value.
You added those two? Wait, hold on. Yeah. Okay.
I added 2,000 times the lower value of both my slope intercept and my, slope coefficient and intercept coefficient.
So you basically did the whole, you made a line.
Yes, I got
With the lower confidence interval.
with a lower confidence range.
Gotcha.
All right. What would be the upper? Well, I think I can drag and do this by just doing if I fix this at using F4, I can drag this and you'll get the same value for the upper. So the house price will be between $31,000 and $603,000. All right. So that's my 95% confidence range of a house with a 2,000 square foot size. That's how much. And what is the mean value? We already calculated was 317,815.
And the 603, let me see the formula.
So it's the same 2,000 times the upper confidence intervals of the intercept and the slope. Make sense? So for the same reason we had calculated confidence intervals earlier, it's the same, because if your boss asks you for what's going to be the predicted house price and you say, well, it's 317, but the house sold for 200,000, he'll say, you're nuts, you don't know what you're doing, right? You're fired. No, I am a statistician, I don't want to take that risk. I'll tell you, I'm 95% confident, it's a big, huge risk, he might still fire you anyway. But you can do better, right? Why is the range so big? Because our R squared was small. We should have included so many other variables to get the right predictions. So you were not doing, I mean, if you're doing just this for your job, you should be fine. We know all of what that is, we know what these are. We know all of this. We know the standard error. All right. What is the standard error? So this is basically the coefficient is for the slope, for the intercept, that is the mean value. The standard error is what we have learned standard error is. It's the standard deviation divided by the square root of the size. So of the sample size. It's exactly that. And if we are using these values, the mean value and the standard error, and calculating the confidence intervals. Use the, let's do this, standard error. You said norm.inverse? I've forgotten. Norm.inverse. The probability mean is 0.025. Mean is this value, and standard error is this value. You should get back that value. No? No? Oh, this is standard error. So, yeah. What it is doing, this is n minus 1. N minus 1. So, 95% lower. What am I getting a different value? All right, why am I getting a different value? What, tell me. 5 extra grade points for this.
What's the
5,
question?
you know the answer. You certainly know the answer. Why am I getting a different answer?
Because there's no sample.
Because you use the
You
wrong
always give me
number.
an answer which is close but not close. I can give you 2 points for it. You
Okay,
got
2
me.
points, I'll take
But
that,
you-
write that down.
No, you can make it better. You know the answer. Or somebody else can make it better. When can we use a normal distribution? When can we not? Hint. He's already told you because of the sample size, right? So what distribution do we have to use? It's a t distribution because the sample size is less than 30.
Yeah.
See how dumb of me, and I'm using norm the inverse. If you did, it's a norm dot inverse, if you did t dot inverse, probability degrees of freedom, no, you cannot do this here directly because then you have to calculate the standardized value of the mean to get this. So, but if satisfy yourself, you know how to do this, go home and whenever you're running a regression, the first one you run,